Hi everyone, and welcome to lesson 2 on how to interact with the open source repo for Superior Agents. So in this lesson, having already downloaded and set up an agent, we're going to take a look into a bit more about what makes the agents tick, and that is specifically the AI that powers them internally. So obviously you've got a choice of models, but you also have a choice of prompts. And how the agents work is they're given a sequence of prompts that instructs them to learn about the market, find out a bit what's going on, or to respond to a notification that has just come in, whether you've set them up to receive Twitter notifications or news feeds or RSS feeds or whatever. And in this session, we're going to go through the prompts as they are now, focusing in particular on the trading agents, and see how they work and also how you can modify them to create your own custom agents. So on screen here, you can see the trading prompts. So these are in the folder marked agent, and then if you go to SRC and then agent again, you have a choice between marketing and trading agents. So I'm going to focus on trading for the purposes of this session. So you have a lot of structure about when to use your prompts and so on that I'm not going to go into too deeply here. But what I do want to go into a bit more closely is the prompts themselves. So the natural language that is going to get sent to the model, and then we're going to receive the model's response. So the first of these is the system prompt. So what we're telling it is what it is and what it's doing. So we start off with, you are a curly brackets role crypto dealer, trader. And what this basically does is this gives it its personality. So in the GUI version, the web client, which some of you may already have tried, we actually let the user pick the agent's personality by writing in a description of how it's going to trade, whether it's more degen, whether it's more conservative, whether it's into memes or AI coins or whatever. So that, in the live version, gets fed into this variable here in the brackets. So whatever the user puts in as a description of the personality, that is the role variable here. Then we tell it today's date, because a lot of the time it's receiving news stories and it's going to need to be able to discriminate between what is recent, what is less recent, and so on. Then we tell it your goal is to maximize metric name. So this could be the value of its wallet, or it could be PNL, or it could be beating the market. Right now in the main, the main branch, we use the metric is the wallet value, but you are absolutely free to change that. And then within time, might be 1 hour, might be 24 hours, it's up to you. We also tell it what network it's on. So right now it's going to be mainly Ethereum on mainnet, just because, and here's a useful hint, the AIs often struggle to resolve contract addresses on other networks. So they notoriously struggle at finding Sol contract addresses and getting those right. And quite often they buy the wrong token, which is why we haven't actually commercialized those agents yet. But if you can find a way to get accurate Sol contract addresses, yeah, you can absolutely integrate Sol in this. Then we also tell it the metric state, so basically the value of its wallet and what coins it has. So maybe you have 50 Pepe, you have 100 Doge or whatever it might be, and then the value of that in USD. So this final line is one of our early attempts to prevent the agent from spending all of its gas money. So we told it the ETH balance shown is your available balance for trading. A small amount is automatically reserved for gas fees, which we actually do. We we prevent the agent from seeing its entire ETH balance in the hope that it's not going to spend it. And sometimes they do. They run out of gas and so on. But this line did not actually work very well. So we replaced this. And this is an example of a small edit that made a huge difference in how the agents performed. So we took this line out, the line about the ETH balance and the gas fees, and we replaced it with this. Do not trade ETH. This is reserved to pay gas fees. And we gave it only a tiny bit of ETH and then everything else in USDT. And the whole goal of this was to stop it from spending all of its gas money too quickly. And just changing this one line made a huge difference to how they trade. Now they're a lot more careful over their gas. But we had to do a lot of trial and error experimentation to get this to work and to work out what was the solution to this. So then we kick off. We have an initial research code when they've done no research, they've got no notifications, and we actually tell them, you know nothing about your environment. Please write code using the format below to research the state of the market. We tell it which APIs it can access, so usually that would be CoinGecko, and also the DuckDuckGo command line search, or Exa search, depending on which we're using. DuckDuckGo, it's not actually an API, but who's counting? We give it instructions on how exactly to write the code, just so that we can be certain that we're going to be able to run it and test it carefully. Then, likewise, we have a similar prompt telling it to do research in response to whatever the latest notifications it's received. We tell it, again, what APIs it has, what its current strategy is, and if it has been trading for a while, we actually retrieve incidences when it encountered a similar situation in the past and tell it what it did in those circumstances and what the result was. So that is the RAG, which is its previous strategy, and then the result, which was the before and after wallet state. We tell it what notifications it got and what research it did as a result of those. And then we tell it, you need to decide whether to trade any of the current coins that you have, or to hold and wait, or do something else. So it could potentially, decide to tweet if it has access to the Twitter API instead of trading to shill its bags. We tell it to reason through its decision process, and then just quickly to sketch out the code that it would use. And this, again, this is an edit that we made to the prompt. So we iterate over these prompts ourselves to improve. Before, in the original version of this prompt, we told it just to write the strategy and no code. And what we found was that it was getting very tempted to write the code anyway. And the code that it was writing was actually quite good because it was coming out of the same latent space as the strategy. So it was actually probably better to get it to strategize and then sketch pseudocode and then debug the code rather than having it strategize and then in a separate prompt turn that strategy into code. So again, this was something that we learned by doing. Then when it's done the research, when it's come up with a strategy, obviously if it's going to trade via a SEX, it is going to need coin addresses, the contract addresses. So we just tell it to do a search and get those from CoinGecko if it can, or Google search if not, or DuckDuckGo or whatever. We also have to be careful. This is another thing that we learned via trial and error. The native token address, a lot of the time it really got stuck. It was really confused by the fact that the ETH technically doesn't have an address on Ethereum because it's the native token. And it got really stuck trying to trade in a lot of cases on account of that. So we had to, again, write in specific instructions for that. And that was something we learned by trying it out. So again, we give it clear instructions on how to format the output just so that we're going to be able to use it in the end. And this gets quite long. We tell it to print, we tell it what to do with errors, and so on and so forth. Having got that, we tell it to, wait, where did I put this? Yeah, we tell it to debug the code that it previously sketched out here. And in this case, what we're assuming is that in the previous iteration, it sketched out the code and put in placeholder variables for the token addresses, which it does by default. And now we're giving it the sketched out code, the token addresses, and saying debug this whole thing and make it functional using these addresses, in the hope that at the end of the day, it's going to come out with code that works, that has the right contract addresses, and that can be run immediately. The final thing I think that is important here is the trading instruments API. So one of the issues is that obviously there are a lot of decentralized exchanges out there, and the model kind of tends to get confused between the APIs of each exchange, especially if there are lots that it can deal with. So it might write a call to Uniswap under the Kyber API format, and then it fails and it can't work out why, and it has to reiterate, and it just takes a long time. So to get around that problem, what we actually did was come up with our own API wrapper that helps it trade. And that is in the file, in the directory structure here, you'll see it under Metaswap API. And what that does is give it basically a one-stop shop for interacting with the DEXs. And we actually wrote this before MCP came out, but it's like a homebrew version of MCP if you've ever used MCP before. So again, we tell it what to use to make the trade. We tell it how to write the code so that it doesn't screw that up. And we tell it how to, not just the format for the code, but also what to do in the event of errors and so on. So raise every error just so that we can debug. And yeah, that is it. That is the full extent of the prompts for this. Obviously, we did a lot of trial and error. In some cases, we gave it a lot more freedom to decide, okay, I don't want to trade. In some cases, we directed it very closely. I think both strategies have advantages. On the one hand, if you give it very clear and direct structure and a path to follow, it's going to get things right more frequently earlier on. On the other hand, if you give it more freedom, it will quite often do weird stuff and get stuck in local minima, and sometimes it just won't learn at all. Sometimes it'll go off and just go nuts. But it has the potential to also do really interesting, creative things that you didn't think of yourself, and potentially to be more general and more AGI-like. So it's really up to you to experiment. This is, obviously, it's a basic structure we're going from doing your research, working out a plan, firming up that plan, executing that plan. And that is, it's a solid structure, but other ways are possible. So like I said, we modified this. Previously, we separated out the planning and the coding completely, and based on our experimentation, we decided not to do that in the end. So if you do want to change this prompt structure, it is definitely possible. We have deliberately avoided relying on chat history for this. The early versions did have chat history, but A, it used a lot of memory, and B, it made the coding massively complex, and the prompt structure, and there's a lot of LangChain and different libraries and so on. So we took that out, and rather than using chat history, we actually use the variables that I mentioned earlier, like role, like like the APIs, like the previous strategy. So in the earlier version, this was done using LangChain. If you've ever used LangChain, you know how complex that can get. And we fed this in via the chat history and via the model's own memory. We got rid of that because we wanted it to be more controllable, more transparent, and more debuggable when things go wrong. But again, if you know how to use LangChain and you want to add in chat history and you want to add in these more complex prompting systems that can often result in more human-like outputs from the model, then again, that is something that you're free to do, and I'm really interested and keen to see the results that you can get by doing that. So yeah, this was just a quick intro to the prompting structure and how that works. And the best way for you to learn how to do this is actually to go and play around with it. Create your own prompts, create your own prompt structures, and see what happens. Thanks for tuning in. Bye.